propellant. From C2 we jump to C3 because it's not possible to get low GWP compounds from not much from C1 and C2s. The closest we got was R32, but then it's still not considered to be low GWP. So people synthesized olefins, and you have tetrafluoropropylene. So see HFO 1, 2, 3, 4, YF, and there are many HFOs. It's just an example. But the simplest molecule you have is HC290 propane, C3H8. It doesn't contain any halogen, only carbon and hydrogen. So we call it HC290. It's considered to be a natural refrigerant because it occurs in nature also. But it's purified by petrochemical processes, and then you get a refrigerant HC290. I don't want to spend too much time on this because this era is gone. CFC era is gone. We have phased out the CFC much before mandated by Montreal Protocol, and India was, for instance, a refrigerator we phased out in 2003. I was involved in some of the, projects, including hydrocarbon refrigerator, cyclopentane blown polyurethane foams, and we introduced cyclopentane in 2002, a long time ago, and we also introduced in India isobutane for refrigerators as an alternative to 12. So we phased out ODSs, what we call as CFC, but in a broader sense, you can say ozone depleting substances. So we phased out sharply as per schedule, but ahead of schedule. Then came what is known as accelerated phase out of HCFCs. This was done thinking that still chlorine loading is very high, and we need to accelerate the phase out of HCFCs. Therefore, it was pushed by about 10 years, and India agreed to do that. And these are the schedules, and we are now somewhere here. Between 2020 and 2025, we are on target. The major HCFCs to be phased out are R22 in air conditioners, R123 in chillers, R141B in foam. So, now if you take air conditioner, virtually in new systems, they don't sell, although it is up to 2025, we don't sell any air conditioner made with 22 now virtually, and all the air conditioners sold are with non-ODS substances, but not necessarily as per Kigali. So we are still using R410A, R32, and one company is still using hydrocarbon 290, but we are yet to do something about Kigali Amendment, but we are reasonably okay with HCFC, HPMP, we'll call it HCFC management plan, and we are on target. And I feel that the enterprises are not waiting for the target dates. In fact, they are switching much earlier than what is targeted. And if you look at the portfolios of refrigerants, you will find that foam is 21% because this is basically 141B, and then refrigeration manufacturing. This is mostly on R22 and R123 in the manufacturing sector, but it's basically using chillers, 22 in air conditioners and 123 in chillers. Then service sector forms a very big chunk of consumption, because R22 and it is used extensively in the ACs, and AC service is the most difficult part in India. It's not only India, but generally Asian bloc, since there are no restrictions on servicing emissions and there are no mandatory training required to be a service technician, the lack of awareness on emission is a problem. Therefore, it has a very high consumption. Then this, if you take in service sector, R22 forms the bulk because that is in split AC and AC, window AC. So from service sector, if you split that consumption, you'll find R22 is the biggest. And then emission from foam blowing, this is mainly from small scale sector, but now it is virtually gone. Although this statistics is from 2015, if you take it today, this will be negligible. And if you take it today, this would have come down because we are now using 22 only in old ACs. But still, it's a fairly big chunk. And air conditioning, you will find that the 22 is the major in AC. But other applications, it's pretty, the predominantly 77% in AC. So when you say HPMP, we are really speaking about two refrigerants, but one refrigerant is virtually gone, 141B. We have phased out 141B. And as I said, cyclopentane has been the major replacement, which is supposed to be a zero ODP and almost negligible GWP refrigerant. And we have phased out foam blowing with cyclopentane. But now we have the major responsibility in tackling R22. And then came this Kigali Amendment. See, Montreal Protocol was basically for that, for substances that deplete the ozone layer. So we were only targeting ODP close to zero. ODP is zero in the beginning, but hydrochlorofluorocarbons do have some ODPs. So we were targeting CFCs with non-ODS substances. But then they found out that we were using HFCs as a substitute for CFCs, and the growth of HFCs are going beyond control. And therefore, they said we can't allow the growth of HFCs as the way it was happening. Therefore, for some reason, which was considered to be a ozone-friendly refrigerant, but not necessarily global climate change friendly. Therefore, the world decided to discuss the possibility of restricting the use of HFC, and ultimately the Kigali Amendment took place, and it came in. India is a party to, has ratified the Kigali Amendment in 2021, and out of 197 countries already, as of May, maybe it is more now, 147 parties have ratified Kigali Amendment, including India. And Kigali is now serving not only Montreal Protocol, but also climate change. Because if you phase down, as per Kigali, HFCs, you will reduce carbon emission equivalent to 700 billion tons of carbon dioxide equivalent, which is a huge benefit to climate change. And already some countries have, restricted the use of HFCs, particularly with respect to GWP values. And the EU is phasing down under their F-gas regulation, and they have the most aggressive schedule in the world. We have a fairly relaxed schedule, and we have quite a lot of time left because we have something like 2047. The baseline is only 2024. The baseline is yet to come. Because if you start from next year, and the average of 2024 to 2026 will be the baseline for India. So we have a long way to go to Kigali. But having said that, world is moving faster. Therefore, my impression is that our industries also, if we have to compete with the global industries, particularly on export market, we have to change faster. And so my impression is the industry will not wait like it didn't wait for CFC phase out. We did it faster than what we were supposed to do for compliance. So similarly, I feel that our industry will also phase down HFCs faster than what is mandated. So it took a while for India to ratify Kigali, although we supported Kigali when it was introduced, but it took some time. One of the major the issue for Kigali is substitute for HFC. We just introduced, and the HFC is made in India now, and they were growing, and suddenly we have a Kigali Amendment to phase down HFCs. And therefore, what happened is there was a lot of discussion. Will it impact our growth, both growth with respect to RAC growth as well as the economy? So there was a lot of discussion, internal discussion. Ultimately, Government of India decided to ratify Kigali, and they ratified it, and we are now working on phase down, and they are consulting industries, but they are yet to come out with the modification of ODS regulation rules, because ODS regulation is for Montreal Protocol, but since Kigali is a part of Montreal Protocol, the Ministry of Environment, Forests, MOFCC will come out with its own rules on how to regulate the growth of HFCs, what HFCs have to be regulated in priority, and how we phased on as per Kigali Amendment. So this is an exercise which they are doing now, and soon we'll be hearing this from the ministry. So as I said, we are now targeting two global environmental issues. One is ozone depletion, another is global warming. And global warming is an independent issue, really speaking. But then somehow the global community decided that it's better we deal with the refrigerant part of. Otherwise, it was only looked at it at Kyoto Protocol, which was looking at 6 gases, because they were looking at gases which were not covered under Montreal Protocol, including HFC, PFCs, SF6, besides CO2, methane, and nitrous oxide. So there were 6 basket of gases in Kyoto Protocol, and some of the gases related to Montreal Protocol. 2 of them was where HFCs and PFCs, but PFCs we are not using in any refrigeration system except in minor applications, but most of them were using HFCs. So since Kyoto Protocol was going slow and it had its own problems, the community decided to link Montreal Protocol with HFC, and they brought in Kigali Amendment. Now we are in two-pronged approach strategy. On one side, we have to phase out HCFCs, and then other side, whatever you do as a substitute must fulfill GWP conditions. So what is the committee I'm involved in, UNAP Technical Option Committee and TEEP. I've been involved since 1990. It's more than 30 years I've been involved. And there we discussed how to classify these refrigerants as per GWP. So you will find that even 300 is not GWP. 100 is very low. Less than 30 is ultra low. So in fact, really now we are targeting to use ultra low. Anything above, some countries are even considering 15 and below. So in future, what is the range of future? I can't tell you, depending on the policy development. Future, it's going to be not more than 30 or so. So any refrigerant So I'll talk about it. There are many refrigerants which are in that range, and they will have problem with that if you continue to allow. But there are time. You see, uh, please understand, Kigali does not specify that you should phase on A, B, C, D like Montreal Protocol. Montreal Protocol specifies the refrigerant. Kigali says you have to phase down. And second is equivalent, carbon dioxide equivalent. So if you can manage with a certain carbon dioxide equivalent and the country does not ban that particular refrigerant, you will be allowed to use it. So it depends on the country's regulation. As long as we are stepping down on carbon dioxide equivalent, the country can choose to use any refrigerant, but feasibly speaking, you cannot do it unless you go to something like 100 GWP. If you are going to use 150 or 200, you are going to have problem in your compliance with Kigali. One of the important elements in the whole Kigali and Montreal Protocol, particularly after Kigali, everybody started looking at refrigerants which will have, which will be like CFCs. But unfortunately, in spite of searching among hundreds and thousands of chemicals, the answer is we are not going to get anything as safe as CFCs. And whatever we are going to get in the future will be mildly flammable or flammable. So therefore, the ISO 817 or AEEE 34 reclassified this flammability because so they created a 2L recently, and then you will see that if it is low toxicity, you have A1, A2, A2L, and A2, A3, and some examples are given. And then if it is toxicity, then you have a B1, B2L, B2, B3. So in B1, in B1, you have only in B category, most common is ammonia. The ammonia is B12. It's toxic, but at the same time flammable. But all other compounds are A-type, and the hydrocarbons will be flammable. Then HFOs will be mildly flammable, most of the HFOs, and the CFCs and HCFCs were non-flammable. So you will have to deal with this class of compounds, A3, A2L, and B2L. Most of the compounds which we'll be dealing in the future will be A3 because hydrocarbons, or A2L like HFOs, and B2L ammonia. And carbon dioxide and air, water, they have no toxicity issues. So if you look at refrigerant progression, you will find that prior to 1930, that before CFCs were introduced, they were using anything that was available as a molecule and with some certain properties like boiling point and latent heat they were using. So they were using ammonia, water, CO2, hydrocarbon, ethers, methyl chloride, methylene chloride, ethyl chloride, sulfur dioxide, and most of them, many of them are flammable or toxic, like SOx, SO2, ammonia, flammable like ethers and hydrocarbon. So they used it because they just wanted to have cooling. But then when CFCs were introduced then they said CFCs were considered to be very safe, and they started using new refrigerants, CFCs and HCFCs. Then we introduced HFCs for in the 90s, and now we have time up to 2047 to phase down high GWP HFCs and Kigali. But if you go to future, as I said, will be only ultra low GWP. which means I have to deal with the natural refrigerants like ammonia, hydrocarbon, CO2, or water, and HFOs. Most of the HFOs have very low, ultra low GWP. So, but as I said, our problem is how to deal with the cost for HFOs, one. Two, they are still flammable, and there are certain standards, safety standards you have to follow. So this is just a scenario. So it should be understood that whatever refrigerant you are going to use, they'll come from 2L or 3. And therefore, they can be applied only with appropriate safety standards. Now, safety standards, fortunately, are in place now, reasonably in place. So I can design hydrocarbon refrigerator nearly 600 liters without any problem for if I follow safety, because the quantity of refrigerant required for isobutane is almost 1/3 of 12 CFC 12 we used. So I can design, likewise, I can design an air conditioner with propane in place of 22 because the quantity used is almost 1/3 or just about 40% or 35%. So standards are there. You need to design and test your appliance as per standard. So this is going to be very tricky for me because I was asked to give an overview of what's happening in the world, and I tried to do it, and I'm running out of time, so I need to do it fast. If you take domestic and commercial plug-in appliances, it's predominantly isobutane. So another few years, 134A in new system will be gone. It will be only isobutane. And in standalone appliances, although we use HFCs and HCFCs blends, many blends, but future it'll be 290, and in plug-in type it'll be 290, and it's happening in India, it's happening all over the world. So because these quantities used on these appliances are pretty small. If you take, I told you, if you take a refrigerator, you are using only 30, 33, 35 grams. Which is less than 1/3 of what you hold in a cigarette lighter. So like that, in terms of safety, although we talk about safety during manufacture and servicing, but now it is virtually done. They are all going to use hydrocarbons because of the very low GWP. It's, they're less than 10. So whereas if you take larger systems for food retail and food service, there it's going to be different because we are using now 404A, 134A, but then they will get shifted to either medium GWP A1 refrigerants. There are some A1 refrigerant, fortunately, but they're not low GWP. So how long it will be used, we don't know, but there are medium GWP refrigerants. And the ultra low and low GWP refrigerants will be carbon dioxide, which is very popular in Europe, hydrocarbon, HFC 32, and blends. So there are quite a few blends in the market, which people are using R454, 454C, 454A, and 455A. These are all blends. And transport refrigeration is basically now the trailers use 404A, particularly whereas the trend is to use 452A in US. 134A can be converted into either 513A or HFC 1234YF. Wherever possible, the trend is to use HFO 1234YF in place of HFC 134A because of property, but it's not a retrofit. You need to still design your system suitable for HFO 1234YF. So this is the trend. In cruise liners, 134A is being replaced with 1234ZE. And fishing vessels, traditionally they use ammonia, so the ammonia will continue to be used in fishing vessels because you need a lot of ice there. And so you'll find that the future is changing. And the air conditioners and heat pumps. Today, majority of the products are switching to, including India, 32, R32. But now people are looking at the medium GWP, lower than R32 is something like 675 GWP. So they're trying to use blends with 1234YF so that you can reduce your GWP. But that is happening in some cases. But with the advent of revision of the standard IEC 60335-2-40, now one can design air conditioner with 290 or with 32 in larger systems with safety. Provided we follow safety, using 32 or 290 is not an issue at all. And that's a very good development because at the time of initial stages of Kigali, we didn't have that thing. And large systems, in some cases, still we are using 22, but then that will go very soon. It will continue in the service sector, but it will go in the new systems. And from even R11 is gone, and we started using 123. So the future will be using. In Europe, the trend is to move towards ammonia. Where even 25 years ago, they started using ammonia for heat pumps. But whereas what we need is cooling. And ammonia is a very good fluid for heating. So if you go to most of the airports in Europe, you will find they are all using ammonia for air conditioning, heating. Whereas we require cooling, so we are not still keen to use ammonia, and we are still relying on chillers. So we have a problem for large chillers, and there is a new HFO which is being tried, and that probably will become the refrigerant choice for large buildings. Mobile AC, now globally 134A is the choice, but if you want to change for some reason where regulations are not allowing 134A, like in Europe, you will use 1234YF. And then for EVs and all that, the carbon dioxide market is opening. So where EVs are concerned, and particularly for heating, they are not doing it for cooling in Europe. So they are opting for carbon dioxide. In vehicles, most of the time it's a replacement for 134A is 134A is 1234YF. And as I said, EVs, it is going to be 744, but there are other options available like HFC 152A or hydrocarbon with a loop. But these are all, we have visited some of the R&D labs, but I still feel it will be either HFO 1234YF or R744. Industrial refrigeration will go to ammonia. As I said, it's going in a big way, and we have a fairly good ammonia base in India, but the only problem is we still do not follow global safety standards. I must say that we are good in ammonia refrigeration, but we still do not have as good a safety record as in Europe. Europe, it's very stringent, and therefore ammonia use is growing in a big way. We are not able to use ammonia even in conventional. So to expand into non-conventional areas like cooling will be fairly difficult because of the cost, but it can happen. Heat pumps, they were currently what is used is 410A and 134A in Europe, 407C as an interim, but now it's all moving towards propane and carbon dioxide. And large systems like district heating, it's ammonia. Some of the largest systems in Europe are using ammonia for district heating. Not in kind, absorption systems will be the most popular, and it is coming in a big way. But there are now, without refrigeration, can you use deep sea, lake water, ocean cooling? And these are being tried in India also, but it's becoming popular in Gulf countries where they are trying to use, because they're surrounded by sea. And if you take water from 1 kilometer depth, it is around 5 degrees Celsius. So you don't require any cooling. You just take the water, or even 500 meters water, and pump it, circulate around, and put it back into the sea. So there is no cooling tower required, no refrigerant, only pump is required. This is the latest issue, which is causing a lot of concern for people associated with the refrigerant choices. Even US is having certain problems with it, but it's a big way in Europe. Particularly, Europe is the one which is pushing for PFAS, perfluoroalkyl substances, and some of the refrigerants having this kind of structure, CF3, and in one end, or CF2, they are all falling under PFAS, saying that they can form trifluoroacetic acid when they break down in the atmosphere. And any, as I showed here, HFO 1234YF can lead to the formation of trifluoroacetic acid, and then they will form trifluoroacetate. So the fluids, refrigerant, which are under threat are HFC 125, HFC 134A, 227A, 1234YF, 23ZE, and 1336 MMZ. These fluids have this, but there are fluids which are not necessarily PFAS. For instance, 32. Fortunately, it's not a PFAS. HFC 152A is not a PFAS. The HFO 1132A is not under PFAS. HFC 23 we are not using except for my very low temperature cooling because it's a very high GWP gas. So nobody wants to touch HFC 23. But the US EPA has, while Europe is saying that we need to look at PFAS seriously in the under Montreal Protocol, EPA is saying, for refrigeration, we will keep a temporary relief for PFAS, but for other cases of PFAS, they are taking action. So it's a mixed feeling when it comes to PFAS. Europe is pushing, US is not that keen, and therefore country like India is caught between the two. You need to understand that future is going to see a lot of blends. So when you talk about blends, you have azeotropes, 500 series. That means they have only one unique composition of blends, and you cannot vary the blend. They are like 502 old one, 410A. I'm sorry, this 410A should not have come. It's only 500, but for 410A is not is an azeotrope. But 400 series, 410A, 40A, 7C, 402A, 404A, they are all near. See, there are two cases of azeotropes and zeotropes. When it's near azeotrope, it behaves like azeotrope because the boiling point range is very low. People tend to think anything the range is less than 5 Kelvin, you can treat it as a 500 series virtually. So 401A, 402A is there, but 410A, 407C they are not. And So this is a big issue in future of servicing, because in when you deal with non-azeotropes or zeotropes, you have a problem when it leaks, because it differentially leaks. The composition in the system changes. If you want to top up, you cannot do it for certain refrigerants with the because the composition continue to vary, and then the performance will fall. So you need to one of the major problems in refrigerant loss, as I told you, servicing sector account for major refrigerant. That's because we don't follow certain norms like Europe or US or Japan. They have certain norms for training the technicians and following certain norms for servicing, and they use kits like this. Now, fortunately, these kits are available now. I see one of my friends attending this webinar who is making Indian versions of these and making a market, but these were not available in the beginning, and they are available today. But still, it's not used extensively by many technicians for many reasons. One of them, I'll just say, is the cost factor. Then, you need all these tools if you want to minimize the leakages. Vacuum pump, the manifolds, tools, cylinders, refrigerant recovery cylinders, and service cylinders, and so on. And leak is one of the major factors for the refrigerant consumption, according for refrigerant like R22 or 32, because the access to these units are very poor in most of the developing countries. They are in a place where somebody has to approach with a lot of risk involved, like in India, parapet walls. So the reducing the reducing the leak is an important factor in the refrigerant management. And if you take most of the risk leaks, there is a survey done, and they found out that it's all through field assembled joints. So now with the flammable refrigerants, the dictum is avoid joints. Only avoid flat joints. Only use the sole joined by a flame. So soldered or flared. You need to avoid flat joints to avoid leaks. And most of the leaks come because of the bad joints, and the small cases lead to maximum. So that means some people tend to overlook safety while assembling it, and they have poor record of, and this results in very low. But this is changing now. People are aware. But one of the problems for India, it's claimed that the technicians are not full-time technicians, and they work on a part-time basis, seasonal basis. Therefore, they can't afford all these things to carry welding machines or torches for brazing and welding or solder joints. So they find it flat joints easier, but that results in leaks. So future, this is going to be changing, because we need, for flammable refrigerant, it's important that you use braced joints or welded joints. So good service practice is an important element. And say the flammable refrigerants adds certain elements of safety for service and manufacturing. If you take, you have to use appropriate tools rated for hazardous area. You have to have a fire extinguisher, a good electronic leak detector, good ventilation fan, reusable canisters. And so these are all important for in this thing. And transportation of these refrigerant is another issue for technician, because he has to carry different refrigerants, but most of the refrigerants future, as I said, will be a flammable refrigerant. So therefore, you need to follow certain standards. And we are for managing a variety of refrigerant, particularly in small scale units. It's going to be a challenge. We have tried recovery and recycling about 15 years ago. Maybe we were too early for the game, but then it has not picked up. In my opinion, we tried giving recovery machines for some mechanics and asked them to practice. After 1 year, when I went and checked with them the record, they hardly had few kilograms of. So it is quite tough. But even in some of the developed countries, the situation is not that good. But because of the regulation, it's driving them. For instance, if they find out that they have leaked, because they have to keep a record of how much they buy, how much they charge, how much they collect. So with this audit, they're able to monitor the progress of service technicians' usage of refrigerant. But that kind of thing has not happened in India, and it's very difficult to happen. So this is going to be a very gray area for us, recovery and recycle. But still, we are working on it, and we are moving towards that. And you have recovery machines available in India market, recovery cylinder, large cylinders, recovery machines. So these things will happen under HPMP. They give, but the thing is, you can give these units under HPMP through a multilateral fund, but technicians need to use it and they have to carry it. So you will need a van to carry all these things. So you may have require about 5 to 10 lakhs depending on what kind of service he does. Otherwise, if he can carry in a small bike, then he only requires a bike and certain tools. But if he has to, even for AC, if he has to carry a vacuum pump and charging cylinder, canisters and things like that, he cannot do it on a bike. So this problem does exist, and it's going to be a challenge for the future. And refrigerant reclamation is another area which we have not reclamation is collecting all this refrigerant and bringing it back to the quality of refrigerant, which was like ISO 12810 or AEEE 700, which means the quality of refrigerant has to fulfill a certain norms like moisture, acidity, and things like that. So therefore, this reclamation is going to be an interesting thing, but it cannot be done by everybody. So you need to create an ecosystem, collection by technicians and depositing it in one system, an operator, and that operator will purify and give it back to the system. It will involve, but who is going to pay for it? That is the problem, because everything is fine said and done. Since we do not have a regulation driving reclamation, so there is no incentive. So we need a procedure, collection center, reclamation center, and redistribution. So it's a reverse of the distribution system. Yeah, refrigeration manufacturer, distribution. Maybe we can consider EPR of the refrigerant manufacturer. They're not going to be happy about it, but it's one way of looking at it. If EPR is introduced, extended producer responsibility for refrigerant, then they have to collect back the refrigerant. So this is not a great experience in developing country. No developing country has mastered and followed it in true spirit. This is known from many records. So mainly cost and logistics. These are the reasons why it failed. Even I put a very modest cost of 3 to 5 lakhs, but it's very, very modest. But if you want to do it, it will cost you much more, much more. So for us, we need certain strategies. We need gas cylinder rules to be modified. We need certain facilitation for collection and reclamation centers. There's a lot we need to do. It happens in MAC sector very well because the volume is big. See, every car can have a kilo, whereas if you take air conditioner in a difficult location, 1 kilo is still a problem. Whereas a car can be taken to a garage and he can recover it. So logistics is an issue for air conditioner. There are approved technologies for destruction. We have only considered cement kilns, but if you go to international, you will find many as per norms. I was chairman of this committee which wrote this report in 2002, and then after that I was not involved. These are the approved technologies for ODS destruction and HFCs, because now HFCs also are coming, used HFCs, cement kiln, rotary kilns, municipal solid waste incinerators, plasma decomposition, catalytic reactor, superheated. And these are all approved either for ODSs, or that is CFC12 or HCFCs, or halons. Halons require much more stringent conditions for emissions than HFCs. As I said, cooling capacity, this is a work of AEEE. Most of these cooling capacities are in building sector, and therefore we need to target in and even the energy consumption is in space cooling sector. So we need to target refrigerant consumption and energy. We need to target space cooling, and therefore energy efficiency is an important element in the Kigali. Unfortunately, although Kigali says energy efficiency, it has not specifically said it will be funded. So it's easy to say we need to improve the energy efficiency. It costs money and it costs technology and new components, but then we need a good strategy for improving energy efficiency. Unfortunately, there are some developments happening, particularly on the G20. The major countries are cooperating, and we may get this going very soon. But unfortunately, energy efficiency is still in India is not comparable with some of the best in the world. If you take many studies prove that it doesn't cost more if you increase the efficiency, but initially you will find that it is creating a cost barrier. But in the long run, the cost is coming down, and virtually it is more or less the same as the conventional models. But we need energy efficiency. Our energy efficiency standards, after BEE introduced a star rating, we have improved, but we are not, in my opinion, we are not improved to the extent to be a global leader. We are still lagging behind on energy efficiency. As I said, Montreal Protocol is also contributing to the sustainable development. And so in our report, we are advised to write how our work is contributing to sustainable development goals. So I want to conclude my talk saying that HCFC phase out now is demanding because of simultaneous coupling with Kigali. So we have two targets. One is faraway target, another is so low GWP and HCFC phase out. We are okay with traditional refrigerant, but we are not that still okay in terms of experience with some of these natural refrigerant like CO2 in certain applications, ammonia in certain applications, particularly with respect to safety. CO2 is high pressure. You'll be dealing with 120, 140 bar. And ammonia, low charge ammonia is very common, but it costs money. And if you follow EN 378 standard in India, it will cost money for putting all the safety gadgets. So it all depends on how we move. Regulations drive us to do. Do we take safety seriously? Will government introduce safety regulations for refrigeration sector? All these things will determine the refrigerant management in the transition. If you miss this, in my opinion, we should take this as a challenge, R&R as a challenge, energy efficiency a challenge, and increasing the new low charge refrigeration system as a challenge, and become a global leader. We should not take it as a hurdle. We must take it as a challenge to be a global leader. Thank you very much. So I'm done with my lecture.
Thank you, sir, for this wonderful presentation. So in this next, we will take a question answer session in which we have requested the participants to post their questions in the chat box. We can see a few questions in the chat box. I will read out them and maybe you can reply or respond to the questions. So the first question is from Mr. Ramesh Kumar. He posted that is it possible to change R22 in old split air conditioners to a better environment-friendly refrigerant?
What is that?
Added,
no.
Yes.
Yeah, please tell.
So the question is it possible to change R22 in old ACs with the new like low-GWP or environment-friendly refrigerants?
No, see, we in the CFC phase out, we tried retrofitting in refrigerators. It was possible. I had done quite a lot of retrofitting. I also have done quite a lot of retrofitting with 407C for ACs. 407C was the only fluid which came very close to 22 in retrofit. The next was 290, but 290 is a flammable refrigerant. So when you do retrofit, you introduce safety. When you retrofit with 407C, you don't have safety issue, but you have a performance issue. So you can retrofit with 407C by changing taking the refrigerant out, cleaning and changing the oil because you need POE, and then charge appropriately and optimize the charge. If you do that, it works fairly well, but it involves a lot of effort. Technicians have to be trained for a retrofit. So it might work for a few days. I mean, in the sense, this philosophy will work for a few months, but in my opinion, nobody tried retrofitting of refrigerator. So I also feel nobody will do retrofitting for air conditioner. They'll go for bartering. So the new refrigerant air conditioner manufacturer will say, come, we'll give you some money. You take new air conditioner. That's what happened with the refrigerator. So same thing may happen. This is my opinion. Thank you.
So the next, Mr. Ramesh raised another question. Can you please comment on energy efficiency of ultra low GWP refrigerants?
Yeah, see, nothing is going to be compromised on energy efficiency because of refrigerant change. Nobody is going to compromise. When you change, you either have to have a equal or even better efficiency with new refrigerant. Okay.
Yes. So thank you. The next question is from Chandan Sarkar. He is asking that are there any refrigerants with less than 1000 GWP for chillers or VRF systems?
Yeah.
Capacity greater than 10 TR.
Oh, yeah, there are many refrigerants even. Say 32 is 675. So when you say 1000 is a very big number. So we should be targeting less than 150 or like that. And even for that range 150, there are refrigerants available.
One question is from Rajesh Kumar. He's asking that HFOs are very costly and it is not suitable for higher capacities. Is there any way to overcome this issue?
No, HFOs, see, HFOs are made only by 2 manufacturers today. And it's also made in India through a contract manufacturing, and they are expensive. I told you, one of the major drawbacks of HFOs will be cost, many fold cost. But there is no way we can do something about it. Nobody is going to give you a refrigerant at a lower cost because of low GWP. It's expensive, so that will happen. That is why India has taken a stand that we will go slow on Kigali. One of the reasons is the availability of HFOs.
So one question is from Vikas Kumar. He's stating that SOPs to change over from HCFCs to HFCs in cold storages. So he is requesting some details on that.
See, you're talking about retrofit? See, the changeover means if there is a refrigerant A is used and you want to use refrigerant B and you want to change the system, there are procedures available, or you buy a new system. But if you want to change the refrigerant A to B without changing the system, but only retrofit, and there are certain refrigerants available. So you need to evaluate, but then in both cases, you have to do certain modification, particularly if you're using any A2L refrigerants, or if you're using HFC today and you want to use A2L refrigerant, then you need to make sure that some of the components are suitable for A2L as per current standard, the safety standards.
One more comment is there that would request more details on low or medium capacity ammonia through pumps, fairly good on safety standards for cold storages.
Today in India, there are people supplying low charge ammonia for cold storage. There are, I don't want to name because then it will mean I'm advertising for some people, but there are suppliers in India, Indian suppliers giving low charge. I want to tell that you are also party to that. ISHRAE is a party. RefCold has a lecture on low charge ammonia, RefCold 2023, which is going to be held on 12th of this month, has a lecture by one of the suppliers, consultants, on low charge ammonia chillers, ammonia, cold storage. These are available in most of the European countries because low charge is a strategy used by them to introduce ammonia in unconventional applications. Because one of the problems of ammonia is both toxic and flammable. That's why it's classified as B2L. And with the standard introduced, one can design large ammonia systems which they are using. I told you 20 years ago I visited an airport, Oslo airport, which was entirely air conditioned by ammonia. Airport. Now you have London airport is air conditioned by ammonia. There are many airports heated by ammonia. But if you go to the machine room, you won't feel that they are having tons of ammonia because that's how it has been designed. We need to follow that. And if you go to fertilizer plant, you will know that they are using ammonia because you will smell strong smell of ammonia. That is in fertilizer plant where safety is already built in. Whereas in a building, if you want to use ammonia, then we need to define the building standards, codes, as well as safety codes for ammonia system. It is possible, and there are consultants who can design and execute in India. Johnson Controls in India, Europe, they have done huge jobs along on ammonia and for large scale star refrigeration in large scale. Both of them will be talking star refrigeration and Johnson Control and ACR Consultant. They'll be speaking in RefCall 2023.
Yes, sir. So next question is from Mr. Avinash Kumar. He's asking that is it possible to record the recovery or reclamation of the refrigerants in India? Like, is there any scheme or?
I see. Recovery machines are available, made in India. I'm sure he's there in. Kapil Singhal is there. So I know that he makes. Kapil, are you there?
Sorry, yes, he is there. But,
okay, he's muted. And yes. I'm also seeing Arvind Surenge from Pune. He's one of the experts in India on low charge ammonia. So, the people are there. I'm not saying it, they are not there, but only thing is the enthusiasm to use such technology should come from users.
So I think Mr. Avinash is asking about the is there any like recording of the recording of data? I think that one is recording this data of recovery or reclamation. Is there any process or any scheme?
No, today we have no scheme because we are not regulating refrigerant use yet. It should be done. I'm saying it should be done. In Europe and US, it's very stringent. In Japan, it's very stringent. You cannot buy refrigerant unless you are registered with through technicians program. And then you have to keep a record of your refrigerant usage and consumption, where you put it, where you collected, and these are audited. And depending on that, you are given next quota. So these things happen in developed country, but it's in our country, it's too early to look at these. And this has to come from the manufacturers, but unfortunately, the technicians are not owned by or supported totally by manufacturers. So most of the technicians are independent, except in MAC, where they are attached to like a franchise. It doesn't happen in AC. AC, they will try. It happens with AC only because if you have AMC, they'll call. Otherwise, independent technician will come and do something, and he may not follow all the protocols of the OEM. These systems will come, but unfortunately, it's taking much more time than it has to happen. We need, because all these things involve cost and time, who will pay for it is the question. So even the government is on a slacken mode because of this reason. Because if they put a condition, they'll say, the manufacturers will say, it will impact our market. So therefore,
yes, sir. So the next question is from Mr. Mukund Ranade. He posted that they are trying to buy some HFOs like R1234ZD or other refrigerants, but they came to know that there are some government restrictions and they could not buy it. So he wanted to know that what are those restrictions by the government?
No, see, I bought HFO to do experiments in Anna University, and we paid a heavy price for it, but I got it because there are certain conditions for HFO when you want to buy as an individual. but because the suppliers don't want to give to individuals because it's made in not in large quantity and it's expensive, so and there are some IPR issues related to it. Therefore, they don't want to give it to you as an individual who can misuse or can handle it improperly and resulting in certain adverse situation. So they don't want to give it to individual. Whereas I bought it after giving a declaration, signing a declaration that I will handle it properly. And I got that refrigerant and we did experiment and published a paper. We worked on a mobile air conditioner in Anna University with a professor. So it's possible to buy, but you cannot buy in small quantities unless you have a good reason to buy. And I was one of the first fellows to import 134A in India when nobody knew. That was in 89, 90. So it is possible. It is possible, but then your intention should be conveyed to them, and you must give a declaration, sign an NDA, and you can buy. By the way, I bought 134A and POE without paying. So it's possible.
Maybe Mr. Avinash Kumar responded this that it is available in India. So in the last, we will give the opportunity to speak on that. But we will take one more question from Mr. Nikhil Sarma. He posted that how 5 mm copper tubing can pave the path to the adoption of new greener refrigerants, such as R290 or with challenges on the evaporator side. So the question is about like copper tubing, how it can help the adoption of the greener refrigerants.
I am not too clear about the question. Is it possible to give the? Is it somewhere available for me to read?
Yes, sir. So maybe, we can get
They call it.
Yeah,
okay. Is this is there any eco labeling scheme for refrigerant? Is that the one?
So sir, I will give him the access to speak. Maybe he can speak out. And before that, we can take another question. Like there's one more question: that is there any eco labeling scheme for refrigerants worldwide and in India?
Yeah. See. Eco labeling. I got the question. I read that, and you also told. Eco labeling is not for refrigerant. Eco labeling is for system. In Europe and US, they have eco labeling depending on GWP of refrigerant, energy efficiency of refrigerants, and performance. So eco labeling, in order to, for instance, in Europe, it has to have something like GWP, I'm not sure, but GWP less than 20. You can't use a refrigerant 32 and go for eco labeling. But if you use HFO or preferably CO2, they give higher rating for eco labeling. So there are, and energy efficiency. If the same refrigerant should also have certain minimum MEPS, minimum energy performance standards. So if you combine all these things, the eco labeling is given. And the most stringent eco labeling is in Europe, particularly giving weightage for low GWP. And so eco labeling is not for refrigerant, it is for system. And we are only targeting performance efficiency. We don't target in our standards. I keep made this statement in my slide, but not made it. Still, we do not have standard for safety standard for appliances. We have safety standard for compressors. We have safety standard for control this thing and tubes, but we have no safety standard as a whole, like what IEC 60335-2-40 says, or 2-89 for commercial refrigeration, or EN 378 for large systems like ammonia. They all say certain things for system. And we do not have a safety standard for air conditioners, refrigerators. We have safety standards only for compressors, only for heat exchangers, copper material. Material strength.
Yeah. So we'll take the question from Mr. Nikhil.
Yeah.
Hi, Devotta sir. I guess we came across your work during one of our project for 5M copper tubing. It's basically 5M copper tubing on the heat exchangers of the RACs. So
Yes.
right now we did some study and we
Yes.
got to know that on the condenser side it has been changed. And your paper on R290 refrigerant was there that it talks about how it can be adopted in a 5M copper tubing in a
Yeah. Yes.
much more
Correct.
better way. So I
Yeah.
want to understand how the
Let me
evaporator
explain.
side can be converted.
Yeah, I'll tell you, as long as you have the phase area on the evaporator, you can still try to reduce your but why we did it condenser? Most of the refrigerant charge is on condenser. Okay, so we concentrated to reduce the charge on the condenser side. When you stop a fluid working system, so we reduce the diameter from 7 to 5, and we were able to reduce the refrigerant charge of R290 from 550 to 380 grams, to 1.5 ton air conditioner. But if you reduce your the evaporator, then you need to increase your fin, which is very difficult because fins become too close to packed, and then it won't act as a fin anymore. It will act as a solid wall, and it will block the airflow or the evaporator. So we didn't change much on the evaporator because you need good cooling area. So it is a problem on the evaporator side, but you can change it, and we did change the bends and all that, but not the diameter, because of we need area, cooling area. Whereas on outside, I can increase the fans capacity, flow rate, or reduce the charge, no problem. We were able to manage that and this was done without affecting the performance. We got better energy efficiency than what it was with 22. Right?
So, sir, one question is from Mr. M.P. Agarwal. He is asking that recovery and destruction of CFC refrigerants need extensive training and some investment as well. So, how can we address it? Please.
Yeah, see, this has to be done by national program. It cannot be done. We are not that environment conscious to take it as a responsibility. But this has to be either done by national program and EPR as a policy. Unless a policy comes on, nowhere in the world this has worked without driven by regulation, either cost or regulation. In Europe, it is done by regulation. They have a huge tax on HFCs. Any synthetic refrigerant in Scandinavian tax like $10 a kilo. So that means he finds it very difficult to buy that refrigerant again. So he will go for a recovery and recycle, or he will go, and there is an incentive for taking it to the. So we need policy driven mechanism and also incentive. It will not otherwise work. I made it very clear in my presentation. You need both regulation and incentive. And we have to facilitate. Government has to facilitate, because I cannot individually take my refrigerant to somebody. A technician will come and collect it. And this happens in, many cases, including old air conditioners. So it can be managed. It is being managed, but it requires a mechanism, and it has to come from the government, and industry has to collaborate.
So we will take the last question, and it is from Mr. Vikas Kumar. He's stated that, sir, as we are heading for phasing out of HCFCs, very soon. So do we have examples in India where HCFCs has been changed over to HFCs with change in lubricant, addition of suction filters, etc. for hermetic compressors? So as I understand, it is about the retrofitting of the
Yeah, it looks like he's asking for retrofit. I told you the only refrigerant which can be retrofit, which can be used to retrofit for R22 in air conditioner is 407C. But you have to change the lubricant, and you have to do. We have done. We roughly know how much percentage of the original charge you have to charge for 407C. So in my paper, I have published a paper around 2003 or so, how to change the retrofit for 407C. If somebody sends me a mail, I can send you a copy of the report, my paper. That was pretty old paper, 20 years ago. And it tells you how to change from 22. And the only advantage there is it's not flammable. So 407C is not flammable. It is still an A1 refrigerant and you can use it. But then if it leaks, it's a problem because it's not a azeotrope. It is a non-azeotrope. That means you have to fill it again after flushing out everything. And you have to change the lubricant there. Please remember. You have to, if you are using 22, you'll be using mineral oil, but whereas 407C, you'll use POE or PAG, depending on what you want to use. Yeah, please.
So sir, the last question again, so Chandan Sarkar is asking that what leakage percentage is considered for GHG emissions calculations as per the Kigali Amendment?
What is the percent? What is the percentage of
leakage? Yes. So
leakage?
I think that yet, as per the Kigali Amendment calculations, what percentage leakage percentage can be considered?
There is no leakage percentage considered in the Kigali. It's a usage of the total usage of HFC, including OEM and the service sector. So the world now is trying to move towards zero leak. It's not possible, but it's moving towards zero leak. So in about 10 years ago, there was a movement called zero leak technology, but it never took off because you know that it's not feasible. There will be some leak, but minimizing leak is the fundamental aspect of refrigerant management. That's why we moved away from flat joints to brace joints, welded joints. And this is much more important for A2L and A3 refrigerant because you don't want leakages to happen. And there are many studies, including I have done some leakage studies and risk assessment in rooms and things like that. So based on that, only this revision has happened. 60335 2-40 and 2-89 happened because of actual experiments of leakages and risk. So people have done risk assessment and then, so leakage in real opinion, in real sense, if you follow the standard, it tells you all the methods to avoid leaks. You have to read the 60335 2-40 or 2-89. It gives a beautiful account of how to minimize leaks.
As we are reaching the time limit, so if you allow, we can take some more questions in next 2-3 minutes.
Yeah, sure.
One question is from Mr. Arvind Surangi, and he raised the question that how do you see the potential for the use of hydrocarbons for the small capacity units?
See, personally, I would welcome because he is a person who can do that. And I've seen in 20-25 years ago, I've seen air conditioners with 290 in Europe, particularly even in the UK, and chillers of buildings, office buildings with hydrocarbon. Because it's only cooling water which comes into the building. Hydrocarbon stays outside. And now there are standards now. I'm talking about 20 years ago when there was no standard which allowed But today there are standards. All standards have been revised. So I still think people like Mr. Surenge should try such things. I can do my best to collaborate with them, because we need to change from very traditional way to what has happened in Europe, to use very low GWP refrigerants, like, district heating with ammonia, unimaginable. But now it's happening all over Europe. Large scale megawatts of a few megawatts of heating with ammonia system. So propane for small scale is not an issue at all. The standards allow quite a lot of refrigerant quantities are allowed, provided we follow the standard. See, now the question is, who is willing to pay for extra safety just because of low GWP of refrigerant? If you get a customer, I will do it, and I can do it.
So, sir, my important question is from Gayatri, and she raised about the compatibility of the components and their economics and availability in India. So, like she posted that there are a lot of low GWP refrigerants available, but the availability of refrigerants as well as the compatible components in India is a huge, big challenge. So, how we will deal with this issue and for challenge?
See, this is a problem for African countries, but not for India, because their demand is pretty low in Africa. So they have raised this issue, and in fact, in our UN committee, we have addressed this issue, availability of components. But for India, it should not be a problem, because Danfoss is in India. Without naming, I cannot mention it because they are one of the major suppliers of components for refrigeration systems, controls, and components. They are in India. Their major R&D is in Chennai. So it should not be a problem, but it's not going to come at cheaper rate now. Everything is expensive. Anything you deal with HFOs and components and oil is not that expensive, because it's more or less the same oil what we are using for. But components, if it is particularly 2L or 3, A3 or A2L, you need controls suitable for that atmosphere, 2L or A3 atmosphere. And standard specifies what components to use, what controls to use, what heater to use, what fan to use.
So sir, there's a long list of the pending questions we could not cover due to the time constraints. But possibly we will collect the questions and we'll send to you. If you can
Okay.
Send the responses to the participants. So as we are like already exceeded 5 minutes than the scheduled one, so that's like we thanks to the speaker, Professor Devotta, and in closing, I would like to extend my sincere thanks to the professor and for his valuable insights, and all the participants for their active engagement in today's seminar. Your contributions have made the session truly meaningful. If you have any further queries, feel free to reach out for further discussion, and we appreciate your time and look forward to connecting with you in future events. So here we end the session.
Okay. Thank you. Thank you.
Best wishes for your continued.
Thank you. Bye. Thanks. I really enjoyed this. Yeah, I really enjoyed, and I'm surprised about the interest of the participants. And I'm also surprised some of my very known friends, including Mr. Surenge, Mukund Ranade, Kapil Singhal, and all that attending. So it's a great feeling. Thank you.
Thank you, sir. So, the participants are also requesting if we can provide the presentation to them. So, if it is possible, you please share this presentation or accordingly.
Okay. Okay.
Thank you, sir.
Thank you.